Okay, welcome back. Sorry for the very sharp cut-off. Midway through doing Paramphasis, my other half was trying to organise a trip out to New Zealand as part of her university course, and she finally found somewhere that would accept her, so she's quite happy. And there's a lot to do there. Anyway, sorry, I'm distracted. Right, back to work. Where were we? So, we're doing parenthesis. Parenthesis lets change the binding power of things, so mathematical parenthesis. Obviously, we use parenthesis for function calls and stuff like that, but they're going to be slightly higher up. In fact, they will come here. We will check in here before we create a variable lookup. We will check to see whether it's followed by a parenthesis, and then if it is, the parenthesis is almost an operator to say call a function with the name of the identifier before it and the arguments after it. So in some ways it's a binary operator. If you think the L parenthesis is sort of like that, with the R parenthesis as the terminator for the list of arguments. Does that make sense? Or is this my brain making weird analogies? I think it becomes more apparent if you write a Prat parser, but that's from memory because it's a while back. Anyway, sorry, distractions. We get a left parenthesis. We record the line number. We move on past it. We call plus or minus. So we might do 10 plus 4, 6 times 8, something like that. We come back out. If we don't have the closing parenthesis, the right closing bracket, then it's an error. So we're going to unplan the parenthesis starting at 19, and then from now we just go abort because I'll exit with an exit success, not an exit failure. Maybe exit failure because that will be a can't actually move the numbers. Exit failure 1, success is 0. That makes sense. Okay. What I actually want to do is we will log the error. Then I haven't decided yet, but if we decide to record more than one error message at a time, we're into a panic mode. We only reset the panic mode when we get to a known good state, like maybe a semicolon at the end of an expression, or even an end of a function, which is for the future. For now, we're just going to exit. Ensure we're doing fine. There's no new identifiers because there just isn't, because we're removing the brackets and we're creating the structure of the tree, which implicitly tells us the precedence, so we don't need the brackets here anymore. Still working. Let's scroll down. Now, what we really want to do is put a bracket here and a bracket here. That means we will no longer multiply the 90 by the unary. In fact, let's get to the unaries because they're just going to be unary operators. This can be confusing. There we going. Yep. So we add the plus to the false before we do the multiply by 90, and then all of it's divided by the end. That's what we do. Now we should have that. Let's check that. Yeah. Let's just get that. Cool. All is good. Parentheses are done. Adding each element to the parser is actually pretty simple. Just a lot of elements to add. Let's have a look what else we've got to look at. Are there any other binary calls? Return? That's a statement, isn't it? And for the statement we're going to need a code block. We could do code blocks next. They're curly braces. statement, function definitions, function calls. Type declarations. You know what? These are all done. Assignment, which is again another statement. These come out from what do they come out from? Brain is slowing down. They were required when we do an if statement or a while statement, so actually ifs are probably going to be expressions. We're going to be highly expression driven. We may even make whiles return have a value, although I'm not convinced that's good. Anyway, right, let's have a go at a function call. Function call binds tightly, so that's going to sit in our atom. I reckon. Is this the atom? No. This is the atom. An awful lot sits here. It's all very simple code though. But this is about to get a little more complicated. No. What would we call it? I just explained how I was going to do that. Identifier if doc +1 tox. We want to peep ahead and have a look if it's not good. If not finished. And doc type equals L paren. Else move it back. Docs plus minus. Okay, we now know we've got a val equals new node AST type fn call doc/line number. And then let's go to there. People could put a function call across many lines, so you want to get the one where it starts at. And that will let us do a function call, I reckon, without any parameters. I can put all this stuff in here. what? We got to go in here. What information do we want? Put S. Function call S slash N node slash strid juicer. That's all we have at the moment. We need to fill out the str ID. Bow slash str ID equals not entirely happy where this is coming out. Str. Okay. It's ugly code, isn't it? Right, it's just about hitting 11 o'clock now. And let's compile and see what I've forgotten. Give me a hint. The I then, is it? I should remember this, shouldn't I? Was it just an I? Unsigned, it's normally. No, it's unsigned. Where are you? That is definitely indicating tired brain. What are we doing wrong? What? God. Stop programming now, Paul. Glass. That didn't look good either. Ooh. That's not good. God, what have you just done? You should be there. Otherwise you're going to be getting a weird thing. There you go, function call. Function call me. Invalid. We don't have any arcs. That's going to be a job for tomorrow because my brain is starting to fail. Tell that because code writing is not nice. None of this code looks particularly good. We will tidy it up and make it nice. can certainly see patterns coming out. For instance, the iterator is not intelligent enough. We want to have a peak, which probably returns some sort of optional, so we don't need to keep doing. We want a next that returns an optional value, so we don't have to keep checking for finished. Once we get nothing out, there's nothing coming out, therefore we know we're done. We want to be able to peak one ahead, again that will return an optional LTOC. And I cannot think of what else. These things will help with the construction. We're also about to start making a linked list of parameters here. Where are we? Yeah, I can already see better ways to do this. These are both not redundant. And I don't need to do that. Don't need to do that. But I do need to change the type. Type equals AST type. Function call. Doesn't that look not a lot better? Moving there, put it back there. You see, this code and this bit of code are ugly, and they should be really if peak type equals L/N. Bang. Done. We don't need to do all this logic. We didn't return an optional. If we have a type that's end of file, then all this sort of falls out naturally, and we don't have to keep dealing with null types and things. So the code is probably cleaner not using an optional here when we tidy it up. I think, well, let's see it fail. It's always fun, end of night stuff. This should fail. Boom, yups. And that should fail. Yes. Error messages. They are very important. It's pretty obvious to say, but the default state of the non-exceptional case when you on your compiler is the code doesn't compile. That's a normal case of when you're running code. Number of times you see this not compile when I'm decoding. So that's your most common route. So you should make sure it provides good information and is not exceptional. The exceptional case is the code compiles when you're developing. Obviously, if you're just doing builds or something like that, that should also be fine. Let's check some randoms. Yes. Doesn't that look good? Excuse me. And we've got this to tidy up as well. I think probably not tomorrow, because I'm probably going to have a relaxing evening with maybe a glass of beer. So probably Saturday night we shall continue with this, unless I get the urge to do it off stream. We've tidied this up. Well, first of all, the other thing we want to do is generating the children, the linked list that we want, which is cool. We will do that by, let me think, we will do that in here in a very explicit way. We can do it in multiple places, so we're then probably going to tidy it up. We'll go for inefficient and tidy. So once we've got that, we've got all the key components for fleshing out the compiler. Before we do that though, I think we'll have a tidy up. We're going to get the better iteration going, because it's a bit of a mess. I repeating myself, and that's a good indication to go make a cup of tea, watch a bit of YouTube, and sleep. Okay, right. I shall stream again probably Saturday. See you.